Welcome to the lesson on solving quadratic equations using square roots. So before, when we were solving quadratic equations, we either factored, used the quadratic formula, and now we're going to just do this algebraically by square rooting both sides. So you can solve the quadratic of the form ax squared plus bx plus c, which is your standard form, where b is equal to 0, so it's really important that you don't have the b term in there, by isolating the squared term and then taking the square root of both sides. So just take a note, b has to be 0 in order for you to be able to do this. The square root of a possible real number can be positive or negative, so there's two possible solutions to these equations. For example, x squared is equal to 4. Well, what can x be for this to occur? X can be positive 2 squared, and that's equal to 4. It can also be negative 2 in brackets squared, because this is negative 2 times negative 2, which is positive 4. So in this case, once you square root both sides, we have to say that x is equal to plus or minus 2. So when we take the square root of both sides, remember that it's plus or minus and then whatever that you have left over. Let's try the first example. It's very similar to the one I just showed you. You want to take the square root of both sides to isolate x. We know the square root of 9 is 3, and because we're taking the square root of both sides, there's a plus and minus in the front. For b, same sort of thing. You don't have the b term in the middle, so we can use this method. I'm going to isolate my x as much as I can, so I'll add 1 to both sides. And then I'm going to divide both sides by 2 to further isolate my x. 6 divided by 2 is 3. Now I want to take the square root of both sides to isolate my x. And once I do that, I'm going to have a plus or minus root 3. Then lastly, for c, we can take the square root of both sides. In this case, we can have a middle term in here if we were to expand, but this method will still work for this, because you could also solve it this way and check to see if any of your roots are extraneous or not. So if I square root of both sides, we're going to get x minus 4 is equal to plus or minus root 12. Then I'm going to add 4 on both sides to isolate my x, and that would be our final answer. This is nice and quick. If you want to do the quadratic equation, you could, because you would have to expand our left-hand side of the equation, which would be x squared minus 8x plus 4 is equal to 0. Then your a is going to be 1, your b is going to be negative 8, and your c is going to be 4. So you would set it up as so. And then once you simplify, you are going to get the same answer. So you have 64 minus 16 on the inside, which is the root of 48. Then I can break this down even further. So the square root of 48 is the same as saying the square root of 4 times 12. Bring the 4 out by taking the square root of 4, which is 2. And then simplifying our fraction here by dividing every term by 2. And as you see, we get the same answer as our other method of just taking the square root of both sides. Though again, this doesn't work always. You do need to check for extraneous roots. So in order to do that, you would just plug in this whole thing back into x and seeing if this is going to equal 12. And if it does, that means you know it works. I'm not going to try it, but I know it does work. But if you wanted to ever check extraneous root, you just plug in the x value. So you're going to have to do it for both positive 12 plus 4 and for negative 12 plus 4. You plug it into your x, subtract 4 from it, square it, and you should get 12. And if you don't, then that is an extraneous root. There's another way to solve as well. We can complete the square and then solve for it like how we did in C, because this format here is in vertex form. So if we were to complete the square, we can get this into vertex form and then solve for it just like how we did here, which seemed a way easier. I did it in 2 steps versus all of this by using the quadratic equation. Okay, so to complete the square, I don't have a number in front of my x squared, so I don't need to worry about factoring anything out. So I'm going to group the first 2 terms together, and then I'm going to do b divided by 2 squared. So 10 divided by 2 is 5. 5 squared is 25. And I have to subtract that as well. Now I'm going to move this 25 out, negative 25, and try to factor what's inside the bracket. So this is going to be x minus 5 all squared. Negative 25 plus 3 is negative 22. I'm going to move the 22 to the other side, then square root both sides. And when I do that, we get plus or minus the root of 22. Lastly, I'm going to add 5 to both sides. And that would be our answer. Again, you can check for extraneous roots. All you have to do is plug this back into the original to see if it's equal to 0. For b, we're going to complete the square. I'm going to put in our b over 2 squared value. So that's 4 divided by 2, which is 2. 2 squared is 4. So we're going to add 4, subtract 4. Now I'm going to group our terms together by taking out the negative 4, and then I will factor. So this x plus 2 all squared minus 7 is equal to 0. Move the 7 to the other side. Take the square root of both sides. And when we do that, we are left with plus and minus root 7. Then we're going to move the 2 to the other side by subtracting both sides by 2. That is our final answer there. Let's do some harder ones. This is where a is not just 1, so we do have to factor out the negative 2 first. So this is going to be x squared plus 3 over 2x, and I'm going to leave the 7 alone because you only factor out the first 2 terms. Again, if you're confused by this, just try multiplying it out to see why it works, because if I do multiply this negative 2 back in, that's negative 2x squared. The negative 2 and the 2 will cancel out and just leave us with a negative 3x. Okay, now we're going to do 3 over 2, and then we're supposed to divide it by 2, which is 3 over 4. And then we need to square 3 over 4, so that is 9 over 16. If you are confused by this, this is 3 over 2 times a half, because we have a fraction over a fraction. You flip the second fraction and change it to multiplication. That is how we got 3 over 4. And then when you square this, you're going to square it with the numerator and into the denominator as well. So we're going to add 9 over 16 and also subtract it. Next, we're going to move this negative 9 over 16 outside the bracket because we don't need it. And once I do that, I have to multiply it by the negative 2. So then we're left with positive. Negative times a negative is positive. 9 times 2 is 18. And we're still left with the denominator of 16. I can factor what's inside the bracket, so it is only 1 factor here, and then have it squared, which is 3 over 4 squared. Then I want to simplify this. And I'm going to multiply 7 by 16, top and bottom, which is 112. I want to combine my fraction. This is 130. Then I'll move our fraction to the other side. Because we have negative 1 technically multiplied by both of them on both sides, if I multiply both sides by negative 1, I'm going to get a positive back. Or in other words, if I have negative on both sides, they would just cancel each other out. Now I'm just left with positive 2 and positive 130 over 16. When I continue isolating my x, I'm going to divide both sides by 2. Or in other words, multiply both sides by 1/2. Okay, so we have 130 over 32. And then from here, we can take the square root of both sides. And this becomes plus or minus when I do that. Then finally, I can move our 3 over 2 to the other side. And that would be your final answer. You can also find this in decimal form in your calculator, which is negative 1.266, negative 2.766. Yes, I understand that that was a very long question and it required a lot of algebra. Be careful while you're doing this because it's very easy to make a mistake here. I'm going to do one more example and then I'll leave you to it to try it on your own. We're going to factor out the negative 5 in the first two terms. I'll leave that positive 2 alone on the outside. 2 divided by 1. 2 divided by 2 is 1. 1 squared is still 1. So we're going to add 1 minus 1. So again, for your b value, that's 2. Going to divide it by 2, which is 1, and then square it, which is 1. So we're going to add 1, subtract 1. I'm going to move this negative 1 on the outside. And when I do that, this negative 5 affects it because I am reversing the factoring. So that's negative 1 times negative 5, which is positive 5. Now I'm going to factor what's in the bracket. This is x plus 1 squared plus 7 is equal to 0. I'm going to move the 7 to the other side. So subtract 7 on both sides. Divide both sides by negative 5. So really I have positive 7 over 5. Now square root both sides. So we're left with x plus 1 plus or minus square root of 7 over 5. And lastly, I'm going to move the 1 to the other side. You can also find this in decimal if you wanted to. It's going to be 0.183 and negative 2.183. On the next page, there are quite a few questions that you can try on your own. Please do those 3 questions, and then when you're ready, press play to see the solution. Here's the solution to the try it yourself. So the steps are exactly the same as the 2 previous questions I've done with you, C and D. You want to factor out any coefficients in the front of your quadratic first, and it only applies to the first 2 terms. And then you want to complete the square and move everything to one side so you can isolate your x, square root both sides, and then remove your remaining number. You can even plug it into your calculator to find the decimal. So go ahead and take a look at this detailed solution. There are more practice questions that you can do as well. There's one more example I like to go through with you, and it's another word problem. So we have a defender that kicks a soccer ball away from her own goal. The path of the kicked soccer ball can be approximated by our quadratic function given to us, where h is the height in meters, and x is a horizontal distance traveled in meters. So we want to determine the distance the soccer ball is from the goal line by solving our equation. So if you want to know the distance the soccer ball is from the goal line, that's here, the horizontal distance traveled meters from the goal line. So what we want to do, it already tells us to solve for it. So we're going to use our quadratic equation to solve for this, because this is rather hard for us to factor. So this is our A, this is our B, and this is our C. So putting it to the quadratic equation, we have minus 3.168 plus or minus the square root of 3.168 squared minus 4a, which is negative 0.06, and c, which is negative 35.34. All of this divided by 2 times negative 0.06. So we are going to use our calculator for this because there is quite a few decimal places. So if you plug all of this into your calculator, what's inside here, you should get 1.247 after you even take the square root of it. Then you want to multiply your denominators together. So you will get 16.008 and also 36.792. So these are our roots for our quadratic equation. The 16 is how far away we are from the goal line, and this is where it landed. So our final answer then is the ball was kicked 16 meters from the goal line, and this 36.8, that is when it landed, and that's how far away it was from the goal line. So for question B, if we just drew a quick sketch of what this actually looked like for our parabola, we're given the intercepts, because we just found them, there are the roots. And we know that this graph has to go higher because our height has to be positive. Our height can't be negative, or else that doesn't make sense. The soccer's not going to go into the floor. So we know it has to look something like this. And with this picture, it kind of gives us an idea of what's happening. The soccer ball has been kicked here, 16 meters away from the goal line, went through the air, and then landed back here at 36.79 meters away from the goal line. So if I want to find how far this soccer ball traveled in general, I'll take where it landed, subtract it with where it started. So that is our distance that our soccer ball has traveled.